So here is another question on simple harmonic motion. So it is given that a block lying on a horizontal table together with the table, it executes simple harmonic motion with time period of 1 second, okay, in the horizontal direction, horizontally, okay, to and fro motion, SHM. What is the maximum amplitude of this simple harmonic motion so that the block does not slide? Okay, so the situation is something like this. So we have a table, okay, on that we have a block. Okay, we have a block lying on the table, and this whole arrangement it undergoes simple harmonic motion. Let this be the equilibrium position, like this, okay. So here, when it will undergo simple harmonic motion, obviously there will be displacement, there will be velocity, and there will be acceleration of this SHM motion, okay. And also here there will be, when the motion will be in a particular direction, the force of friction, it will be in the opposite direction, okay, like this. And there will be, okay, the downward gravity, force of gravity, the weight mg, and the normal reaction force, okay, that. So here the coefficient of friction is given, okay, 0.4. So here the condition so that the block, it does not slide from the table with both the system, that is the table and the block together moving, is that the maximum acceleration, or the SHM acceleration, the maximum value of that SHM acceleration multiplied with the mass, the total mass, which is the force of SHM motion, it should be equal to the force of friction, so that they will cancel each other out and the block will stay where it is, okay. This is here mu into Fn is equal to mu into mg. So this is the condition. These two should be equal so that they cancel each other out, okay. So here it will be mass, for this mass will get cancelled from both the side, okay, and here, so it will be the maximum value of SHM acceleration, that is equal to omega square into a, where a is the amplitude. Suppose the motion, SHM motion, is represented as a sine omega t, a is the amplitude, this is the maximum value of the SHM acceleration, that is equal to mu g, okay, omega square a is equal to mu g. So here time period is given as 1 second. From this we can calculate the value of the angular frequency omega, which is equal to 2 pi by t, which is equal to 2 pi by 1 radians per second. So here that implies the maximum amplitude we have to calculate a. So mu g by omega square. So that is equal to 0.4, we'll take 9.8, then omega square, which is 2 pi square. So this result, it is coming around 0.099 meters. So basically it is how much? 9.9 centimeters. Okay, rounding it off, it is coming 9.9 centimeters. So this is the value of the amplitude, the maximum displacement of the SHM motion. Okay, so we are asked to find the maximum amplitude so that the block does not slide. So for this nature of SHM motion, we had to calculate this value A, and we got this 9.9. Okay, so this is the thing. So here is another question on simple harmonic motion. So it is given that a platform moves up and down with simple harmonic motion, the total vertical movement of the platform being 10 centimeter. What is the shortest time period permissible if the objects resting on the platform are to remain in contact with it throughout the whole simple harmonic motion in the vertical direction? Here we have been given the value of acceleration due to gravity, g is equal to 980 centimeters per second square. Okay, so here it is given that we have a platform, let's say something like this, and we have, let's say, some object on it. This platform, it is undergoing simple harmonic motion in vertical direction, okay, up and down motion, and it is given that the total motion, vertical movement from one extreme to the other, that is equal to 10 centimeters. That is the total movement, total motion. So it means if this is the equilibrium position, then on either side of the equilibrium position, the extreme point, it is 5 centimeter away from it. So this is the amplitude. So we know that a simple harmonic motion, it is represented by y is equal to a sine omega t. So here a is the amplitude, it is 5 centimeter, omega is the angular frequency, and t is the time at which we have instantaneous displacement y. So here, if let's say an object of mass m, it is placed on the platform which is undergoing simple harmonic motion, so obviously a force of gravity mg, it will act on it, and because of the up and down motion of the simple harmonic motion nature, there will be a force due to simple harmonic motion which is equal to m into acceleration of the SHM. Okay, this. Now for the object to remain in contact with this platform, this force of SHM, okay, the maximum value, okay, the maximum force because of the simple harmonic motion, it should be equal to, it should be basically lesser than or equal to the force of gravity, okay, that is equal to mg. So this is the force of gravity, and the maximum value of simple harmonic motion, that will be equal to mass of the object into maximum value of acceleration. Okay, so here we know that maximum value of acceleration in simple harmonic motion, that is equal to omega square into a, where a is the amplitude, omega is the angular frequency. So that implies m into omega square into a, that should be equal to m into g. Okay, mass into acceleration due to gravity, that is equal to Fg, and this is equal to force of simple harmonic motion. M will get cancelled, that implies omega square A is equal to G. That implies omega square is equal to G by A. That implies omega is equal to root over of G by A. Now we have been given value of G is 980. Okay, 980 centimeter per second square. A is 5 centimeter, which we determined because the total vertical motion is 10 centimeter, 5 centimeter on either extreme side by 5 root over. So that is equal to how much? It is coming around, it is 1. Okay, it is coming around 14 radians per second. Okay, 14 radians per second. That is the angular frequency. Now we know that time period is equal to 2 pi by omega. So that is equal to 2 pi by 14, which is coming around 0.449 seconds. Okay, 0.449 seconds. Okay, so this is the thing. The time period is equal to 0.449 seconds, which we had to calculate. So here the basic principle is to equate the two forces acting on the block. First, because of the SHM motion, the acceleration of SHM, the force of simple harmonic motion, and then the force of gravity, mass into acceleration due to gravity. So for the objects to remain in contact, this HM should be lesser than equal to Fg. So we are using this equal to part to get the exact value. Okay, so this is the time period. Okay.